Okay, cool. So the next question I would like to cover is this. We got to find the missing number in this sequence, or I guess series of numbers. So first we got 9. I'll just rewrite it here. We got 9. We got something. We don't know yet. That's what we got to figure out. We got 6,561. And then we have 430, 467, 2, 1. So we're trying to look for the missing number. But to find the missing number, we first kind of got to know what's the pattern? How do these numbers relate to each other? Well, my preferred strategy for looking for patterns like this is we want to have like two terms that are like close to each other or like immediately after each other. So in this case, we got the 65, 61 followed by the 4 million term. Yeah, don't need to worry about reading that out. Okay, so let's see. We're probably not going to be doing addition between terms because like we're going from 6,000 to 4 million. Like that is a jump that is large to the point where it's unlikely that we'll be adding. So most likely we're going to be multiplying by something to get there. So let's divide these terms. So we're looking for what multiplies. What multiplies 65, 61 to get to 4.3 million or so. So let's do that division. 4, 3, 0, 4, 6, 7, 2, 1 divided by 65, 61 is equal to something that I'll figure out with my handy dandy calculator. Four, 6, 7, 21 divided by 6561. And the answer is 6561. That's a familiar looking number. It's almost like maybe the rule is that the current term is the previous term squared. If that was true, that means the missing term would be 9 times 9, and the missing term would also be the square root of 65, 61. Is that the case? Well, let's find it out to see if like the actual rule is like current term is the previous term multiplied by itself. If that was the case, it would be 9 squared is equal to the square root of 65, 61. Because like if to go forwards in the pattern, we're multiplying it by itself. And to goes backwards, well, we'll do the opposite of that, which is taking the square root. So 9 squared, thinking back to my times table, that is a solid 81. And pull out the handy dandy calculator again. The square root of 65, 61 is 81. Hey, would you look at that? That means 81 squared becomes 65, 61. So our missing term in the pattern is 81. So to rewrite the pattern, we got 9, 81, 6561, and then 4,304,672. Whoops, that's not even 4 million. That's 43 million. Maybe I shouldn't draw those commas because they can confuse us with the commas used to separate our terms, but that would be our final answer for the sequence once we find the missing number in the series. Super cool. And it would seem that the solution that we're given agrees with us. So I got to verify that solution by saying the above solution is correct. Nice. So that allows us to move on to our next question.